just started.
Good morning. I hope you had a good coffee break and some nice discussion with your colleagues. Yes, we are here today this morning to try to provide you some information on additive manufacturing and some DOA aspects related to this. First of all, thank you for proposing this topic to the agency for this workshop. The survey we ran before the workshop, in this survey, the additive manufacturing score quite high, so that's why we are here today in front of you. How we built this presentation together with Wolfgang, who is structural expert in large airplanes department. We thought to have two parts. The first part, Wolfgang will go with you through some technical aspects of additive manufacturing, including challenges, including the EASA strategy, some events we are organizing on this topic annually. Also, he will present you some developments in the area of industry standards and some available guidance material. In the second part, I will touch on some DOA aspects, type design, material specification, process specification, interfaces, in particular with production organizations, and also what is the impact on DOA if we have a significant change or not when a DOA is contemplating starting additive manufacturing activities. And in the end, some closure remarks. So I will invite now Wolfgang to go with you through the first part.
Thank you, Alex. So just I have to take a deep breath because a lot of people here. And I would say, let's put the focus on you first. So may I ask a question to you? So how many of you can raise your fingers, have to deal with the additive manufacturing technology currently? Or, okay. Well, it's somehow congruent with our general observations. So, but I think I can focus a bit more on the first three introductory slides, which are more technical, to explain what it is. So what you see here, I'm afraid it's not a good quality, but you may see this is a kind of CAD system which is building up layer by layer the electronic part. And so it doesn't take so much time, but you see the part is being built up in an electronic way. And with the additive manufacturing technology, we can do it with hardware. So this is a big difference. It takes a bit more time than just doing this via bits and bytes, like here in the picture. But there are different technology. They have all one in common. This is, you have meltable material or fusible material, and you will melt it layer by layer and build up the part after a certain long time. Different technologies for this are available, so you can do this with laser melt techniques. A laser is melting material, or with an electron beam. So electron beam is also melting the material. You have just in detail slightly different possibilities with the methods and advantages and some disadvantages when you compare them. And so we go just to the next slide. When we see this technology, it's quite nice actually. You have kind of starting material, feedstock material we call it, which is mainly metallic or polymers. You can get it in form of powder or in form of a more solid wire or piece of plastic. And all this will be melted in the second process in a machine, which you see there, which shouldn't be somehow a black box. It should be more a white box like it is depicted here. So with white box, I would like to express you should know what the machine is doing in detail. because it may have influence on your material, which comes out after, on structural strength or fatigue properties. So, and then finally, after the print process, you will have some nice shiny parts. They're looking good, just ready for installation, you would think. But this is not really the case. So you would have to do some post-processing for this part. So that means surface finish to remove the surface roughness, which also can initiate cracks. And you would have to be sure that the bulk material is really okay, no voids in there, no hollow things with unmelted material. And so you have a lot of uncertainties in the final part. You have uncertainties in the machine, and you have uncertainties in the input material. For example, in purification of the material, when you have oxygen, too much oxygen in your metal powder. So lots of things can go wrong during the melting process, and you don't get the material you would like to get, or you are used to get from the machining area, let's say. So we have a lot of questions. Then it's not an unsolvable problem. So you have just to put a bit of effort into it to understand the whole process behind. And we come to the next one. So this is the old area, you know. So we have big piece of metal. We machine it so that we get finally the form or the shape with the part. And of course, you are producing a lot of metallic waste. You would have to reuse this, and so it costs a lot of money. And this is a big disadvantage. And with the additive layer manufacturing, so you can build an object just with the material you need, more or less. So you build it up layer by layer, and you don't have so much debris. And you have other really big advantages. So you can reduce the material needs and the costs up to 90%. So this is a maximum value, I would say. And you can do through specific design also a tremendous weight saving, up to 40%. So the parts, just going back, which you see there on the right side, the part in the background is the original part, and the part in the foreground is the part which was additive manufactured by using a specific design. So where you just leave the load paths, the material where you have the load path transfer. So you can really, for this part, have a weight saving of 60%. This is quite something. Okay, going back again. So we don't want to do this anymore. Of course, the optimum thing would be if you could print everything. And there we have to propose our strategy. So we are at an airworthiness regulator, normally being approached by such a technology, and we don't know that much about. So we have to gather some experience, and we have to rely on the industry to have information exchange, to understand the technology and the processes behind, and the product which is being produced, and its dedicated use in aviation. So this is a very important thing, number one. The second one is we have to identify a potential safety environmental risk. So is there a specific risk on the part when we don't know the material properties, or there's a widespread in material properties? Of course there is a risk, and we have to be aware of this, and we have to try to mitigate those risks. So we are working closely together with the industry to get all those information, to discuss all those things, and also with the NAAs, who are under responsibility of the surveying of the POAs, of the production organizations, who are applying those machines, of course. The further step is, once when we are aware of what are the risks and how can we mitigate, so we have to monitor the evolution. The machines will be developed further. So they started initially, let's say, with a one laser machine for metal melting. So I will just, to make it more easy, to refer to the metal process. There are others as well, so but it's too less time to explain this. So for the machines, for example, for the metal melting that is being done with a laser system, they started with one laser. In the meantime, we have quad laser machines. So we have 4 lasers which doing independently the melting. And this is a further development, and we have to see if this is has got an influence on the product as well. And we have to check if our means for mitigation are still effective or not, or if we have to do something more. And that means we have on a frequently base to review and revise implementation of strategy as necessary. This is in those 5 points our main strategy, first of all to understand and then to track everything in the further development. So I guess one of the main questions from your side is, do we need any new additional requirements to cope with the new technology? So we have to do more effort to show more substantiation, which is, of course, involved by spending more money. And this is possibly not very much appreciated by you. The answer is, currently we don't need new requirements. So our top-level requirements, Part 21, the CSs, are enough. They cover everything. I will come later to the main paragraphs which are dealing with this. And we mainly would like to remind how repairs and design changes have to be done in detail, and what is the impact of AM on design organizations or on product organizations and on maintenance organizations. So this will be explained a bit more in detail in the second part by Alex. The requirements. So the governing rule is the 603 requirement for materials. It says the suitability and durability of materials used for parts, the failure of which could adversely affect safety, must be based upon experience and test, conform to specifications, meeting design data, of course, and consider environmental effects, temperature, moisture, etc. So this is the requirement we start with. The next 2 about the materials is, starting with the 605, the fabrication method, and this is the additive manufacturing, obviously a new technology, a fabrication method. They must produce a consistently sound structure, so without any spread of material properties in the best case. And this is where we have to be sure. So if a fabrication process, such as gluing, spot welding, or heat treating, so the spot welding, or let's say the laser welding process, comes close to the additive manufacturing with laser melt methods. So all this requires a close control to reach these objectives. The process must be performed under an approved process specification. And to the process specification we come later. It's also a very important thing. This belongs to the EASA strategy as well, that we are involved in developing those process specification. And we have the B, each new aircraft fabrication method must be substantiated by a test program. Okay, that says all. So when you buy such a machine, it's a new method, you have to do some substantiation. What would be the extent of this substantiation? Well, it would depend on, would you like to produce critical parts, safety critical parts for an aircraft? Then there's a lot of substantiation. And we would switch to the 613. If you have less critical or non-loaded parts, let's say polymer material in the cabin, kind of armrest cover, well, you would possibly just have to do the fireproof testing. and that's it. So this is not safety relevant if you have there a broken material finally. Huh? So that shows a variety of parts. It depends on the criticality. Yeah, for the criticality, most critical parts, so we have really the tough requirements of 613, which says mechanical strength properties and design value materials. Most of them for metallic material, that is being done already. We have them MMPDS, the material handbook, where you have lots of material values in there with different heat treatments and different production ways. So, well, you have the rollings in ST direction and so on. So you have all important parameters for the materials listed there. But on the additive manufactured material, we don't have anything there currently. So this is, for example, one thing where the industry together with the authorities are working on, to have an additional chapter in the materials handbook in the MMPDS on the additive manufactured hardware, let's say, or material. For the 613, of course, when you have critical parts to produce, we have to establish design values on a statistical basis. We have the so-called A and B basis. This is a different confidence level. So we have for the A, confidence level of 99%. So that means when you check the material, the properties should at 99% always be the same when you have hundreds of samples. And this would have to be done for the additive manufactured parts or material as well, so that you would have to do a statistic, produce a lot of samples, do a lot of testing, and to find out if your process is really stable, producing good material. So the other side of this is, to gather experience on this new technology, we just arranging workshops with the industry and with other authorities together. And the first of them were quite generic, just doing presentations to see how far the people are, what are they doing. And we did the first one in 2016 in Cologne, and second one the year after, and turned out to be a good thing to do it every year. So, and you see the development. So the first two ones were generic to get a rough overview of what is being done with this technology in the industry. And then it gets more specific, similar to this workshop here, with breakout sessions before the presentations, so that all participants can really discuss the points which are very important for them, to discuss their needs. And we've tried to do this as well now. So we've changed to a more specific topic on the additive manufacturing. One of the first ones was 2018 with the machine knowledge and training. So we've invited machine producers and the users, and we let them just put them together and let them discuss, so what are the needs? And we found out for the machine producers was very important to know about the requirements in aviation as well, so that they can tune their machines and that they have an understanding for the big need of precision and repeatability of the material. Yeah, you see, so we have done the 6th workshop on additive manufacturing 2 weeks ago here in Cologne. And in the meantime, we do it together with the FAA. We have a combined workshop in additive manufacturing to harmonize our work, the very early status, and it, I have to admit, so it worked quite fine. And we do it now on a basis that we do it here in Cologne and the other time somewhere in the US. And it's being organized on a common basis by both parties. If you're interested, I think for most of the workshops, you still have material to download from the EASA website. So there you can see what was the outcome of discussions and what are the presentations, so you can get a rough overview of this. And an additional thing is to be involved into the standardization work. So that means we have to have specifications for the material, for the machine process, And this all has to be discussed with the industry, with the experienced people who are working with the machines. They know what are the bad things you can encounter. And there are some subgroups for the specific specifications. This is a powder specification, the feedstock material. That means you feed the machine with, not with ink and paper, as we know it from at home. So you feed it with metallic powder or polymer powder, for example. And there's a specific specification necessary for this because it's you have to, for example, you shouldn't mix powders from different batches or lots. This may be dangerous. You should have a powder income control, and you should store the powder accordingly to, well, most of the time moisture is an issue, so you should store it under specific conditions. So all this will be mentioned in those specifications. You have process specification. That means for the machines itself, the electron beam, EBM, the laser beam melting, the powder bed fusion, the wire direct energy deposition. Those are the main methods we are using. And in those specifications, it's fixed. What are the problems? What kind of parameters you should have constant and under control? And then we have the material specifications. Do we have to make a post-processing of the material? For example, there's a very famous hipping process, hot isostatic pressing. For some small voids, which are, let's say, non-really melted powder in the material, for small areas, you can heal this material via post-processing. The hot isostatic pressing is, you do it really at high temperature for 3 hours and under 1000 atmosphere. You leave the material there. It's short below the recrystallization temperature, and it will be healing, and small voids will be vanishing there. So it doesn't prevent you from doing fatigue tests on those samples as well. But it's solvable, and some OEMs have shown when they put a lot of effort into this, they have a high repeatability, even higher than for castings. For castings, we have, you may know, factors we put on those to cover flaws in the material. And for the additive manufactured parts, so some OEMs who put a lot of effort and money into this, they found out if we do so and hold all the processes stable, we even don't need a factor like for casting. So it seems to be a good way. This is what we are working on. The green ones are the published standards from SAE. You can just briefly read. You have powder specifications, laser powder bed fusion process specifications. They're the 7003, and so on and so forth for different materials. You have Inconel materials. You have the most advanced one is the titanium 64. So it's 90% titanium with a bit aluminum and vanadium. Those are already published, so you can purchase them. And if you want to use one of those materials, so the strong recommendation from our side is please go into the specifications and try to work along them. Those forthcoming ones are these here. So they are still not published, but they will come. So we have, for example, a process specification for the electron beam, powder bed fusion, and so on and so forth. So this is something which you can, where you can take some time and just go through it and make yourself confident to it. A further thing is, we try to give you a bit of guidance. So for that reason, we are tracking the technology. We're trying to get some information to be experienced, and not to say, well, we can't say something on this because we don't know anything. We know indeed something on this. And in the meantime, So we have issued in April 2017, just 1 year after our first workshop on AM, a certification memorandum, which doesn't invent something new. It just reminds you what our expectations from regulator side, which requirements are the most important. And I've just marked the red ones there. These are the structures requirement because I'm the structures guy. There are some others. We see the engine requirements, we see propeller requirements, we see the Part 21, and so on and so forth. Those are mentioned there, and we have explained why we need those requirements and why you have to put a bit more focus on this and put a bit more effort on this under the light of additive manufacturing. And of course, the purpose and scope of this guidance is that we would like you to really work on our expectations. Yeah, the next step is to update those because we have those guidance materials, because we have realized that there may be some issues I've mentioned before with the non-loaded, non-critical parts. So you may not to do the whole 613 paragraph, which you've seen with the statistical values, the A and B values. So that would be a bit overdone, of course. And so for you guys, the business has to be going on. And I think so those things, when you classify them as non-critical, can be done under a very, let's say, light way of substantiation. And there we would like to issue some guidance in the new update of the CM. Can't tell you a date when it will come out, hopefully next year, sometimes. So we will make the approach on the criticality, which I've already mentioned. And yes, and the statistical material properties, for them you may get an exemption for non-critical parts and less loaded. This is the idea behind it. And the last slide from my side is we will give you also some guidance for the POAs, DOAs, and the MOAs. There's a possible need to increase awareness of closer relationship between those organizations, because of course there is an interference. So we would like to give some guidance on that. And yeah, and of course to make aware of the existing rules there. And now it's Alex's turn. That was part number 1. Alex will proceed with part number 2.
Thank you, Wolfgang. Okay, after you have seen a little bit of technical aspects of additive manufacture, we'll go now through some DOA aspects. First of all, I would like to show you a short, small statistics. We did, through the DOA team leaders, beginning of this year, a survey. And according to the answers, still a limited number of DOAs are involved in additive manufacturing activities. I've seen earlier when Wolfgang asked you, I've seen a lot of hands on the air, but still that might be not so many DOAs yet involved in additive manufacturing. There is also a large gray part here, so some of you maybe have not yet make up your mind and not provide a feedback to us on this topic. I will come back at the end with, let's say, a recommendation for this. Now, you may ask how a DOA may start additive manufacturing activities, and I took maybe a simple example. Hopefully nobody will recognize your design data here. But yeah, you want to manufacture a part through additive manufacturing. It will be enough to say in the notes, for example, that this part has to be additive manufactured. Maybe the answer is no. So you may need to actually refer a process specification for doing this part through additive manufacturing. And you have seen that from Wolfgang's presentation that this process specification is particularly required in some of the CS requirements, some of the airworthiness code requirements. And if this is the case, then obviously your manufacturing specification, your material specification will become part of your type design. And as such, we are expecting a little bit of more elaboration from the DOA side. You have seen already the additive manufacturing is depending on a large number of factors. And then depending on the particular application, loaded part, non-loaded part, plastic, metallic, different type of processes involved, you may have to come up with a process specification. And I just want to present a few items which might be part of this process specification. Don't take this list as an exhaustive list, it's not. You have to explain what is the scope, what type of additive manufacturing process you are defining, what is the applicability, what are the limitations, for example, what kind of parts, what type of parts you may manufacture according to respective specification. What are the materials? Of course, you will have to refer material specification, but you may have also to add handling requirements for the material, storage requirements, and so on. What is the machine, equipment, and tool used for manufacture, including the machine manufacturer, the type of the machine, calibration, maintenance. Facilities are important as well. The machine environment may impact on the result of the manufacturing process. And then you have to describe the process, the preparatory work, the printing steps, what are the key parameters, what are the post-processing methods you will apply to the particular manufacturing process. And of course, you have inspection and test requirements and some part markings. Again, the list is not exhaustive, it's just trying to provide you a hint on what kind of topics have to be addressed in a manufacturing process specification. You have seen that there are already quite a number of industrial standards available. You may refer in your process specification these standards as applicable. But you may also need, depending on the application you intend to use, the additive manufacturing, you may need to qualify the process to demonstrate that the process complies with defined specification and to demonstrate that the parts can be manufactured in a reproducible way. I want to highlight maybe here that this material and process specification are not only part of the type design, but again, answering to some CS requirements, to some airworthiness requirements, they can be considered also part of your compliance demonstration. And as part of type design, the changes in material and process specification are, of course, subject of changes to type certificate process. Now, I think already Wolfgang mentioned a little bit on interfaces between design, production. There is a clear link. There are specific aspects you need to address in these interfaces, like transfer of design data, generation of the manufacturing data by the production organization, and as I mentioned in the previous slide, the qualification of the additive manufacturing process. This all is done together with the production organization. And yeah, I've seen already, sitting at the table there, I've seen already some of the questions you started to ask. We'll have maybe a little bit of time at the end to address some of these questions. But indeed, there are additional challenges if the manufacture is done under maintenance environment and not a production environment. And we are looking to these aspects. And for the moment, I would say that manufacturing is not additive manufacturing in a Part 145 organization is not possible according to the current rules we have, but we are looking into this aspect. Now, significant change for a design organization or not? Again, depending on the particular applications in which you intend to use additive manufacture, there are quite a number of activities you need to develop. And of course, we are looking to have these activities performed according to your defined procedures. So you need to have procedures for defining process specification, for defining material specification, and for qualifying them as needed. If you don't have such procedures, according to the requirements we have in 218247, we will consider that if you intend to introduce this procedure, it's a significant change to your design assurance system. However, even if you have already these procedures in place for defining process specification, material specification, if you intend to use these procedures first time for additive manufacture, I would encourage you to discuss with your DOA team leader and offer us the opportunity to be next to you when you are starting this new activity. Of course, reviewing your significant change for introducing additive manufacturing, we will look to usual topics for this, which is type design definition, configuration control, how you classify changes, how you establish a certification basis, how you use the qualification of the process of the manufacturing process, what kind of testing is involved. You may use supplier as well, so we need to look to the interface with the suppliers, with the production organization, and to look to the training as well, which is important for a relatively new technology which you intend to start activities on. We will work normally together with production, with POA team, which can be an EASA team or an NA team, depending on the case. Some closure remarks. So I would restate the suggestion, the recommendation to contact your DOA team leader and discuss your additive manufacturing intended activities. You may also contact our internal EASA working group on additive manufacturing. You have some contact details there. There are all kinds of discipline structure, propulsion systems, cabin safety, DOA, POA, maintenance cover in this working group. Wolfgang showed you some of our events which are organized each year. So I would recommend you to follow these events. There are dedicated events where you can, of course, get more information on this topic. And follow also our news, the latest, for example, the latest issue of the J News as a small article on additive manufacturing as well. Thank you. And if we have time, we can probably take a few questions.
Yeah, I think we can take a few questions. Some of them that were asked are already answered by your presentation or Wolfgang's, but there are still a number of questions. I don't know whether, Wolfgang, you want to start, or Alex, we have some on the screen.
Yes, I can take one of them. By the way, within the LOI framework, will there be requirements timeline for additive manufacturer to not be novel anymore in the eyes of EASA? My comment on this is not actually an answer, but is more a comment if you want. Actually, the novelty is not referring to the agency itself. We are looking to novelty for the respective DOA, for the respective applicant in the respective project. So novelty may still be there for quite some time.
Okay, next one, possibly from Erhan. If requested design part is no structural purpose, just for cosmetic parts. This is what I've tried to explain, so that there are indeed some cases for non-critical, less loaded parts, like the famous coat hanger or armrest covers out of plastic, where you really have reduced requirements to fulfill. So, and this is what we are coming up with in our second issue of the CM. So we will try to give you there some guidance where you have easy certification, let's say, and where it would become a bit more difficult.
I think on the other we touch a little bit already.
Yeah, there's another one. This is from Trevor Jenkins. Process variability. How does that mean for? Yeah, this is the thing. What I've tried to explain as well. So, how you would have to produce the data. This is according to the 613, and if you have, first of all, you do a classification. What do you want to manufacture? Critical, less critical, loaded, non-loaded. And due to this classification, you go possibly when it's critical into the 613, you have to do the A and B basis. This is explained there as well in the AMC material. So you have finally to do a lot of samples and show that your process is stable and the material properties have a confidential value of 99%. So that means almost always the same properties. Another one from Mario Pirozzi. Other than new requirements, are you considering new CRE? Or, well, the CRE will just be taken as a kind of tool to make aware of our CM. So yes, indeed, we have CRE for this. We also have a generic CRE already, but I think it's not available on the, well, it's not officially available for you all. So you would have to contact EASA first and then involve the project certification manager or one of those experts of the AM group. And then we can spread this CRE material to you. And that means you would have to describe in detail what you want to manufacture. As I said, the classification of the part. And then in the CRE will just be written that you have to refer to the existing guidance material, the CM, which is issued already.
Okay, maybe one more question due to the time. I don't know who wants to choose one. The first ones I think were already answered.
There's one. May I take this one from Trevor Jenkins as well? So this is about the repeatability. Well, I think it vanished from the list. The second was? Yeah, exactly. So what manufacturing process variables are critical to establish repeatability for serious production? This is exactly what we try to transfer with the standardization material. That means the process specification, the material specifications, which had been worked out by industry and authority in the SAE working group, and by the way, of course, also in the ASTM working groups. So you would have to take those materials, and then you can see what is being considered as the most critical parameters due to repeatability.
The one on deviations and special conditions by additive manufacturing parts on ETSO assemblies. I don't know whether you can answer to that. We can take that question back and try to answer it offline. Okay, thanks a lot, Wolfgang and Alexandru.